All right, so I'm going to switch to the virtual machine, which I have open already. Okay, we're going to open up a terminal. Okay. All right, so let's navigate to our folder. I'm going to call this performance. Okay. So that's basically the idea. So now, remember, this is performance in terms of speed between, something symmetric and something asymmetric, such as AES versus RSA. So you just have to think of how you would do this experiment, okay, in a way that it should give you how long it takes to encrypt some kind of a plain text message. So let's say we're going to need some kind of a file. Let's call it message.txt, right? So I just wrote this to kind of illustrate what this is. Now let's go over here. Let's create a file, message.txt. And, let's add maybe 16 numbers in this. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 0. And then 5 more. 1, 2, 3, 4, 5. Okay. So I'm going to do Control X, Y. That's -L. Has a size of 17, I think, because of the new line character, probably. So let's do nano. Yeah, so I'm going to go. Okay, let's try that. So it's 16. All right, so you start at some consistent number, right? And we're going to try to encrypt this file. All right, so I'm going to, for the sake of convenience, I'm going to write a batch script on this one instead of a Python script. Just makes it easier, but you could convert it to Python if you want to. All right, so let's go ahead and do that. So this is, again, the way to do the experiment, basically. So let's call it compare.sh. So the idea here, we're going to have an encryption. We're going to need to generate the keys, obviously, because that's RSA. So we can do that outside of the script, okay? But we'll need the keys. So we'll do RSA. I'm just writing what we're going to be doing. RSA encrypt of the file. Then we can do RSA decrypt, right? And then we're going to do probably, yeah, AES. And for so we're going to, in a loop, repeat the encryption, let's say 10,000 times. And then we're just going to measure the time it takes from before we start until after. And that's it. We're going to report that result. Does that make sense? Yeah. So let's go ahead and do that. So I've written these just to kind of give us some information. So we can do, I think this is in Sage. So that's just the interpreter that we can use, the shell. You can use echo here to just issue a message, such as, pay attention to like the spacing that I'm using. Bash is not as forgiving as Python is. So any little error, it's going to complain. And then we do start. It should be enough. Then you might want to print out some information about what you're doing. So here we can say echo, do RSA encryption of 10,000 times. 10,000 times. Okay, guys. So does that make sense? So we're just repeating this, because otherwise, if we just do it once, it's like fractions of a second, and we're not going to be able to see the subtle differences. So that's kind of what you want to do. Okay. All right. This shouldn't take more than 30 lines of code, I think, at most, with a lot of print statements. All right. So then the command is what we're going to add. So to calculate the time, so we're doing RSA encrypt first. You remember that the decryption exponent is way bigger than the encryption exponent in RSA. So we're going to calculate some times, system times. So I'm going to do start with that. And I'm going to say 1, and I'm going to assign to it. And here, watch out for the spacing again. So just put the equal there. And then you can say the system command. So bash, if you're not familiar with bash, it allows you to basically, whatever you type on the terminal, like you would type ls, etc., you can just put that into the bash script and it'll run. That's the kind of the nice thing about it. Okay, so it's very convenient that way. So I'm going to do date and date. Pretty sure that's a tilde, right? So then you're going to use this key, which I don't know if you can see it, but it's on your upper left-hand corner where you have the wavy line. There's another key that looks like a little accent thing. All right, so use that one, and then date, and then space, and then we're going to put in a format string, so you can put single quote plus %s, and then close up the tilde like that. You guys see that? So maybe I can make this a little bit bigger. So hopefully you guys can see it there better. Got it? Any questions? And this is just so that we can get the dates, okay? All right. More notes. Okay. Then we can do we start the for loop basically, right? So I'm gonna do that's really it, just to calculate the date and time. We're gonna take a difference after. So we can say for, and then watch out for the parentheses here. Just write it exactly like this. So this is more like how you write for loops in C++. So I equal 0, semicolon, I less than, and then here just 10,000. Okay. So again, we're just so that we can repeat this. And then here, semicolon, space, I plus plus. So I'm pretty sure you guys are very familiar with this approach, familiar coding classes. Right. And then now we're just going to do the actual encryption. That's it. I mean, it's that straightforward. So here we need to write the word do, and then we need to write the word done, kind of to open and close the for loop. And then I'm just going to do 1, 2, 3, 4, although spaces don't really matter. Indentation is not a thing in batch that much as it is in Python. So here, as you can see, all I'm doing is I am invoking OpenSSL pretty much as you would write it on the terminal. Okay, so you can pretty much know. The only thing I haven't done is I haven't generated the keys, but I think you guys know how to do that. Public and private keys, right? Keep in mind, you're not sending this message from Bob to Alice, so it doesn't matter which key you use. You're just encrypting and decrypting with the same matching pair for this performance experiment. So I do OpenSSL and then RSA utility, RSA, and then dash encrypt, which should be a familiar command to you. And then you can do pub in, and then dash in key. And then you would take what? The public key, right? Public.pem. So these are the keys we're going to generate. Public pem dash in would be the, oops, space. Dash in would be the message as well. So we already created that one. Right. And so this is a way to do this. Then you can do dash out and you would generate the message. So this is message encrypted dot bin dot bin. And now what I'm going to do here is called a redirection. So I'm just going to redirect this so it doesn't print out, right? So if we did this, it would print out information. But because we want to do this in a loop, I'm just going to do, oops, sorry. I'm going to do, oh, this is fine. I moved the done all the way down, didn't I? Yeah. Right, like that. And then let's go to the end of this one, and then we're just going to do redirection 1 like that. You'll learn about this in 372. When you guys take 372 is the Linux class, you'll learn all these little tricks. Okay, if you haven't taken it already. We're gonna redirect to dev null. Okay, and dev null is just in the system, and every Linux system has this interface called dev null, and it's basically, imagine it's like a black hole. You just throw whatever you want in there and it's gone. All right, so discarding. All right, so this is so that we don't see any output. Okay. And then we can redirect also. There's 2 parameters usually, 1 and 2. One is the value, one is the error. So we can redirect that as well. All right, so just write that in, and hopefully then when you start to run this 10,000 times, there will be no output on the interface, and we don't want that affecting our calculation. Does that make sense? All right, now we've done this part. So we would assume the encryption has ended. So now we just want to measure the time it took. So we do the same as start 1. We do finish 1 probably. And we assigned to it. Pretty sure that is so small. Sorry. That's a tilde. Sorry about it. So tiny. All right, so we do this symbol here. Okay. And then you can do date. And again, this should be single quote. So you're going to do plus percentage s, which is a format string, right? Common terms in Python and C. And like that. Okay. So we have the 2 variables that we have computed. And now we should be able to just take the difference of them and print it out. So we're going to test this. I'm going to do now here. you can say, let's say value, 1, and we're going to assign to it. Well, these should be the tilde. There we go. All right, and we're gonna type echo and then take the difference of them. So do that in double quotes. You'll reference the variable with the $sign. Okay, this is just bash syntax. So it's gonna be what? Finish 1 minus start. Okay, and then pipe into C, and that should give us our result. So now let's print this one out. So you can say echo total time to encrypt with RSA is $value 1. And we should be able to test it. I don't think this will take that long. We can change this to 1,000 for now, just so that we can see the result faster. Make sure you get rid of these comments because it'll break with those. All right, so I think that should be enough. Yeah. Questions? That's it. So it's a simple one, and then you would just do this for decrypt and then for AES, and the point is to get how long it takes. And to make a comparison that is apples to apples, you got to think a little bit about it by changing some of the parameters possibly, but this should be the actual syntax. So let's go ahead and run this one. So I'm going to do sh compare .sh. Okay. Bad loop variable 169. Okay, so what is the error here? The bash is definitely it's not very forgiving at all. So it obviously got to here. I want to say the error could be here. Okay, get rid of this space here. Okay, maybe that'll take care of one of the errors. Nope. Okay. And so the error is in that date here. Okay. All right. So yeah, like I said, bash is not forgiving at all, right? All right. So let's try adding a few things back. So let's add the for loop. Okay, let's try that one. Okay. On the GitHub to see if I have this. And if you guys fix the error, let me know.
I don't think we need to tell them.
You don't think so?
Yeah. Maybe we need to use this.
Okay. But right now, I think the error I'm getting is in the for loop. I'm trying to see what it could be.
That overflow says that that for loop doesn't work in .sh, you get a bash.
It does. Okay. Oh yeah, we're using. Okay, so we are definitely using dash. It only works in bash, you're saying?
Yeah.
Okay, that might be true. Right. Okay. Yep. Nice. Good catch. All right. So either find the dash version, or invoke bash. Good catch. Thanks, Ben. All right. So yeah, so let's go back to the code. And that's basically the for loop. Doesn't seem like it took that long, right? Really, all we care about is how many times. So it's doing 1, 2. This currently is only doing 1,000 iterations, and every time is grabbing the message and encrypting it, right? And now we don't have a public and a private key, so there's also that issue. Okay, so, but we didn't get an error because, why didn't we get an error actually? Because I did this, right? The redirection, the number 1 and number 2, and I just sent those to the black hole that is dev null. So we got no output. Do you guys see how that works? So actually that worked out nicely. So we need to do now the encryption, generate the keys, right? So I message I have, but I don't have public PEM in this command. So we need to do that. And we've done this several times. So we are going to generate the 2 keys. So we can do that outside of this code. So I'm going to do Control X, okay? And now let's do ls-l. We've got compare and message. So then you guys know how to generate your keys. You do open SSL, gen RSA, right? Oh, gen RSA dash pass out pass colon the password 13579 that we've been using dash out private dot pem 1024. Okay, so keep in mind this is the size of the key that we're using, the seed that we're using to generate our prime numbers, which generate our n and all that. Any questions? Okay, so let's proceed to generate our key. All right, so hopefully that's the private key. We have a private.pem. We can cat it. Note the size, it's big. Now we're going to generate the public key. So we can do open SSL, RSA dash pass in pass 13579 dash pub out dash pub out, and then dash in will be private dot pimp dash out public dot. Got it? This is the exact same command that we have used in the past. Hit enter, ls-l cat public, and you can see the keys. Questions? All right. So now we're going to perform the encryption of the previous example. So let's go ahead and do that. We go to nano compare. We want to now uncomment the finish statement so we can calculate when it stopped, take the difference, print out the result. Everyone with me? All right, so let's go ahead and do that. So that's probably 8 seconds, right? Was that 8 seconds?
Mine was 3.
Huh?
Mine was 3.
Yours was 3 because you have better computers. You all have better computers. But yeah, that's obviously it's going to depend on the performance of your computers.
Mine was 16,000.
16,000. 16,000. 1/16th of a second, you mean?
No, it just says 16,000.
But 16,000 seconds would be
Long, yeah.
a long many minutes. So there's something wrong there, right? All right, so maybe just take a look at this. I mean, you can time it with, take a timer, and this is not exact, but it's relevant as because you're conducting the all 3 experiments in the same machine, so you can at least compare. So make sure this is a plus %s, this is date, and that they're consistent. Okay. Any questions on this one, guys? All right, so now we can proceed to do the next one, the decrypt. So it would be very similar, literally. We can probably just copy and change it. So we're going to do a copy here. To paste, okay. So now we're going to do oh, we should also copy the message. Do a copy. Okay. Paste. All right, so we can say here, do RSA decryption. Decryption. And yeah, you're going to want to change this from 1,000 back to 10,000. So that's like it takes a bit longer, basically. Okay. So then here, do RSA decryption 10,000 times. We're going to, the variables, let's think about this one. Yeah, let's keep them separate. So then we can do here start to, right? But then the command should be the same, get date, get the %s, and then the for loop for 0 to 10,000, right? I++, and then the operation is going to change. So open SSL, decrypt. Now, to confirm that this is working, I would recommend that you try this command outside, right? Just to make sure it is actually doing the decryption and everything, that there aren't any errors in the terminal. So do OpenSSL, RSA utility, decrypt. Now you can get rid of this pub in. Instead, do in key, and now the in key is going to be what? Since we are decrypting, we're going to do private.pem -in the message. The message is now the encoded version, message encoded bin, which we should have, right? .bin. Okay, that should be it. And then done. Then here we're going to change this finish to finish 2, get the date, and then value 2, echo finish 2 minus start 2. Okay, and then we're going to say total time to decrypt with RSA is value 2. You guys understand? So this is how you do the code, right? What I want you to do is really think as much as possible about, the parameters. What is apples to apples? Oh yeah, please.
So the deck out would be a different file name. For the OpenSSL.
Yes. Thank you. So we can actually say, that's a good catch. -in, we don't need to write, basically. Or we can do that text, but 2 or something. Encrypt it, maybe, right? Something like that. Got it? Let's go ahead and run this one. Control X, Y. Okay, it's going. And that's kind of how you can do this experiment. Play with it, convince yourself. But at the end of the day, the screenshot that I'm looking for is the one that prints out these times. Okay. And in theory, AES should be faster than the RSA algorithms, at least definitely the decryption. Okay. Obviously, I did 10,000 times this time, so it's going to take, should be 8 times 10. What, like a minute? Questions? Pretty easy, right? Pretty clear. All right, so let's let it run, and while it's doing that, let's talk a little bit about the next approach. So this is encrypt and decrypt of RSA. The last part of this is to do the encrypt or decrypt of AES. Now, should the encrypt and think about this, the encryption and decryption of AES. Should the encryption take longer than the decryption, or should the decryption take longer than the encryption, or what do you think? Based on your knowledge of the algorithm, right? You can probably answer that question. It's an XOR operation, right?
Decryption would take longer.
Why? It's an XOR, right? So remember, we actually did some math where we went from cipher to text, text to cipher, and the operation was kind of similar, right? We would just go to the for loop in one direction or go back, and we always had like about the same number of blocks. So should be more similar, right? Shouldn't be that big of a difference. So you can probably just do one or the other. You guys understand? Because you got that XOR operation, which gives you that stability from encryption to decryption. All right, so it is taking a long time. There it is. Okay, finished. Yep. No. 74 and 79. What do you think?
Pretty similar.
Pretty similar. But then again, it's a small file, not that many encryptions. So maybe if it's bigger, you know, it's like exponential, right? As you increase the size, the difference becomes bigger. Decryption did take longer, even though it's the same file, right? Same parameters, which is kind of consistent with the fact that the decryption exponent is bigger. So do you guys see what I'm saying? 74 to 79. Okay, got it? Making sense? All right, let's do the last part and then we can move on to PyCryptoDome. So to do AES, it would be a very similar approach. So I'm going to do clear here. Just copy it again. Okay. Okay. So now we're going to do AES encryption. So do AES. Let's do encryption. Encryption, okay? You'd repeat it also 10,000 times. So we're going to start with start 3. Got the date here before 4K to 10,000 times I++. And now we're going to change the algorithm. I'll just rewrite it so I don't get confused. So OpenSSL AES dash 128 CBC dash K, and then you're going to give it a key. Okay, so you got to think of, this is what I'm saying, you're going to have to do a little bit of research, right, and figure out, like, how do I compare RSA to AES? What would be the equivalent parameters? You guys see in key size and things like that, but I leave that to you to kind of fill that in. And so 128 AES 128 CBC dash K, and then like we've added the passwords here, 01 00 01 02 03. Zero 4 0 5 0 6 0 7 809. A0 A0 B0, no, that's B, yeah, B0 C0 D0 E0. Yep. Okay. Just some password. Be consistent with it. But again, this is what I want you to consider. And then we have to give it the initialization vector. We have seen this many times with AES. And then this can be, again, something similar, 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 0, 8, 0, 9. Zero A or A0, B0, C0, B0, B0. Okay. And then dash in is the message itself. .txt. And that should be it. Okay, so this is just an example. And now you know how to run the three, AES and RSA. And then let's just change the parameters for the date. So this would be finish 3. So then we would do value 3. We do finish 3 here. Start 3. And then finally value 3 down here. That's it. So yeah, that's pretty a little bit repetitive. But basically this gives you the code or one piece of code. You may try different approaches to measure performance. Got it? Any questions on this assignment? So this is the code that you should use to complete the performance example. At the end of the day, AES should take less time. RSA decryption should take more time. And then RSA encrypt is somewhere in between. If we have the right parameters. Now we are using the same file for all, so that's good. We are using the same number of iterations, 10,000. And then just think of the key size and all of that to compare in terms of security, okay? So that's basically it. That is the code for you guys to complete the homework assignment that is due tonight and on Saturday at the latest. Right? Questions? Yes, go ahead, Tim.
We just use the built-in command, like,
There's a built-in command.
is that okay?
Mm,
It kind of showed the same thing.
if you can show it in a very meaningful way, but I would still want you to do this. I mean, the whole point of this is important, actually. I want you to, this is an example, but it's important because people design OpenSSL and they don't just look at security. This is what I want you to understand. There's an element there of just like, is the performance there? Is it fast enough for the digital world in which we live in, where you want to see your movie 10 seconds after you download it, not an hour later, right? And so one of the methods using RSA would not be practical in many sense, at least in this sense. Got it? Yeah, so it's just one idea that I want you to take away from this. Okay, guys, any other questions? If I'm not hearing any questions, then we're gonna switch gears and just work on PyCryptoDome and try to finish that up. Remember, I wanna give you all the functions. All the code is already on the GitHub for PyCryptoDome, so you can just get it from there. And I will just go over it in class. And then once I've given you all the code, I'll assign a set of problems. And then I will ask you to demo them starting next Thursday. And you'll need to submit a report as well. Now you can imagine that the questions I'm going to ask you are achieve confidentiality, integrity, authentication. Same thing you've been doing all semester. I'm not changing that. So it's like you're going to do a digital signature. You're going to, and you're going to have to do this demo with a partner. Okay. And I may choose, okay, I might say, Tim, you send to Ben, or I might say, Ben, you send to Tim. So you all of you need to know how to do it. You can help each other out, but you should know how to do it. Okay? Because I may ask, can you do it? So this is kind of like the final way that I know that you understand the concepts before we move on to the practical exam and then the last set of topics of the semester. All right, so did it finish for some of you? Those of you that have faster computers? There's a syntax error. Okay, okay. For the AES to print, is that? If it breaks, okay. Yeah, it could break. It didn't break. So what? You have an issue, questions? Yeah, so how do you interpret these results? How do you interpret these results?
AES is faster.
AES is faster. That's what I'm trying to show you. That's it, right? And so you're now somebody building OpenSSL, the movie. So you're going to ask the question, we're going to encrypt the movie. What do we use? Well, is AES secure enough? It is, as long as you exchange the key securely. Okay, then yeah, let's go with AES. Let's encrypt the whole movie with AES because it's faster and people want to watch their movie. And there's a symmetric key that needs to be exchanged, and we're gonna use RSA for that because it's only one time, and that is basically SSL. Do you guys see that? That's whenever you hear SSL, if you might remember at the beginning of the semester, I said, we want to know what SSL is, but I can't really explain it to you right now because you won't understand it. Right? But now we're at week 11, and I'm telling you how SSL works, and you should be like, okay, yes, I understand because there's all these elements. This is how SSL works. Got it? All right, so there will be a question on SSL on the written exam, so hopefully you'll be able to answer it, okay? Got it? All right, that's it. So that's just, you could submit this as a homework, and just show this, justify it really well, okay? And understand that the performance of AES here was better. Any questions before I'm gonna stop this recording, and then we're gonna switch over to PyCrypto. Any questions? Okay. All right, so let's go ahead and do that. I'm gonna hit stop here.